Section 1.4, measuring and constructing angles. A lot of things that we'll do in this section are similar to things we did a couple sections ago in 1.2, except now we're going to be talking about angles instead of segments. Okay? So first of all, what is an angle? An angle is a figure made up of two rays that have a common endpoint, and it looks like that. Okay, so this is an angle. Okay? Y is called the vertex. Very important that we know what the vertex is. The vertex is where the two rays both extend out of. Okay? The two rays here are yx and yz. There are four different ways to name this angle. Well, there's three different ways, but four answers that would be correct to name this angle. Okay? The easiest and not the best way to do this is to just use the vertex. So to name this angle by its vertex, we use a little angle symbol. So I just draw a little angle like that. And the vertex here is y. So that is angle y. And that would represent that angle that we drew. The second and the best way to do this is to name 3 points. Okay? Use the vertex and a point on either side. So for example, angle x, y, z, or angle z, y, x. Notice what's in the middle both times. Y, the vertex. The vertex must go in the middle. Doesn't matter where x and z go, but y must go in the middle. That is the best way, and that's the way I encourage you to do this all year long, is to use 3 points. The fourth way, which sometimes is good, sometimes is not good, is use a number. Why is it not good? Sometimes the number's not there, for one, and two, if it's an angle inside of another angle, which we'll see a lot in this chapter and further on, you can't really tell what number is what. So here, yes, we can call this angle 2, as you see the 2 in the middle of the angle there. But I would not encourage that. I would simply encourage you to use the middle one with 3 points. All right, so let's try a couple of problems here. Number 1, name the angle in 3 ways. I'm going to do 4 ways just for practice here. I can call this angle Q, I can call it angle 1, or I can call it angle PQR, or I can call it angle RQP. All of those are correct. At this point, pause the video and try number 2. Now, number 2, there's only 3 answers. You can see there's no number there. So there's only 3 different answers that'll work here. All right, welcome back. 3 answers here in any order. Angle J, angle HJK, or angle KJH would all be the same correct answer. All right, number 3, and this is why you cannot always use the vertex. Look at the 3 angles here. Hopefully you see the 3 angles. All right, there's one here, there's one here, and there's a big one here. 1, 2, and 3. If I said angle B, you would have no idea what I'm talking about because all 3 angles have a vertex of B. So we cannot call any of these angle B. Instead, we must use 3 letters for each one. Now, B should be in the middle of each one. So how about we start with this angle, and we'll call it angle CBD or angle DBC. Either answer would be correct. You don't need to write them both, either one. And now this angle, angle DBA or angle ABD. Again, either one is fine. They mean the same thing. And then lastly, the big angle, angle CBA or angle ABC. So 3 different angles using 3 letters for each one. Next thing here, you probably know this, you've probably learned this before, but just in case you have not, let's just clarify what these types of angles are. An acute angle can be anywhere from just above 0 to just below 90. Can it be 0.1? Yes, it can. Can it be 89.99? Yes, it can, as long as it's not 90. Because if it is 90, we call that a right angle. An obtuse angle is anything bigger than 90, but less than 180. And of course, a straight angle is exactly 180. And that's as big as we're going to go for most of the chapters in this class. There is one chapter later on in the year that will be bigger than 180, but we are only going to go between 0 and 180 for most of the chapters in this class. Okay, so just looking at this picture here, classify each angle as acute, right, obtuse, or straight. NMP. NMP. Well, that looks bigger than 90, so that one is obtuse. QMN. See that little box right there? That little box inside of an angle, that tells you that that is a right angle. That is 90 degrees, so QMN is a right angle. PMQ, and that one's less than 90, so that one is acute. Next part, using a protractor. We won't do this very often, but it's important to know how a protractor works. On a protractor, there's a top number and a bottom number. The top number would be if you're looking at an acute or an obtuse angle, and then the bottom number would be the opposite of that. So if I'm looking at DEG, just looking at that, you know that's acute. So do you want the big number or the small number? If it's acute, we want the small number. Now it looks like it's 55 or 125, right? We want the 55 because it's an acute angle. Now for GEF, that's an obtuse angle. So now we want the big angle. So that angle will be 125. Again, we're not going to do much with that, with the protractor in class here, but it's important to know what it is and how it's used. All right, this next page here, this is a lot of stuff that we've kind of already done with segments, but now we're going to talk about angles. The measure of a big angle can be found by adding two smaller angles together, just like with segments. Also, just like with segments, angles that are congruent mean they're exactly the same. So in this picture, these two angles are the same, so we say they're congruent angles. We mark those with tick marks, except this time we call them arc marks. So an arc mark could be just one little arc like that, or it could be two arcs like that, or it could be arc and a dash like that. Again, it doesn't matter as long as you use the same one. Angle bisector, just like a segment bisector, an angle bisector is something that cuts an angle into two equal parts. Okay? So it could be a segment, or a line that divides an angle into two congruent angles. So in this picture, VW is called an angle bisector because it cuts that big angle exactly into two. Okay, using this picture here, we're going to answer a couple questions. Find angle CFB. So there's angle CFB. Well, we know this is a straight line, right? A straight line is 180. So if this angle is 78, CFB must be 180 minus 78. And those angles have a special name that we'll learn in next section 1.5. So 180 minus 78 is 102. Number 10, EFA. EFA. If the angle is congruent to DFE. DFE. Well, if these are congruent, they must be exactly the same. So if DFE is 51, EFA is also 51. Number 11, EFC. If DFC and AFB are equal. So DFC and AFB are equal, which means this must be 78. Those also have a special name that we'll learn in the next section. So to do this, we're going to add the two smaller angles together. So adding 51 plus 78 to get our big angle here, which is 129. And finally, EFA, if DFA is a straight angle, sorry, is a right angle, my fault. So if DFA is a right angle, which we can see it's not, but for the problem it's saying it is. So we're saying this is a right angle, which means it's 90 degrees. If that's 90 and this is 51, we can simply do 90 minus 51, and our answer is 39 degrees. All right, for 13 and 14, T is in the interior of PQR. So I'm going to start by drawing that. I'm going to draw angle PQR. Now, important to know here, which letter is the vertex, the one in the middle? That's Q. Does it matter where P and R go? No. Put P over here and R over here, or you could switch those. It doesn't matter. And it says T is in the interior of that. Okay? This is the interior of that. So put T anywhere you want in there. How about right there? And let's draw a ray QT in. Now the picture is done. We can look at our problem here. PQR is 25. So PQR, this big angle, is 25. RQT, this little angle, is 11. And we want to find PQT. PQT is this angle here. Well, we know that measure of angle PQT plus 11 must equal 25. Small angle plus small angle must equal big angle. So we subtract 11 from both sides and we get measure of angle PQT must be 14. Okay, number 14. Same picture as the last one because we still know T is in the interior of PQR. So I'm just going to draw that same picture. And this time it says PQR, this big angle, is 104. But now we're being told that QT bisects it. QT cuts it in half. So that cuts that angle in half, which means these two are equal. So all we gotta do is take 104 and cut it in half, and both of these angles must be 52 degrees. All right, last page. We're gonna do both these problems together because they can be a little tricky if you haven't seen one like this before. So once again, T is in the interior of PQR. So we're still sticking with the same picture here. T is in the interior of PQR. So PQR, and T is in the interior of it. And now we're being told that PQR, so PQR is this big angle, is 12x plus 4. RQT, which is this little angle, is 3x plus 16. And PQT, this little angle, is 7x minus 6. So using what we learned recently here, we know that little angle plus little angle equals big angle. 7x minus 6, little angle, plus 3x plus 16, little angle, equals 12x plus 4, big angle. Now it's an Algebra 1 problem. Combine like terms. Subtract 10x. Subtract 4. Divide by 2. And again, just like previous sections here, x is usually not our answer. We are being told to find measure of PQT. So put 3 back into there. We get 7 times 3 minus 6, which is 15. Okay, last problem here. Once again, T is in the interior of PQR. But this time, we're being told that QT, once again, bisects it, which means these two are equal. So PQR, this big angle here, is 5x minus 6. RQT, this little angle here, is 2x plus 1. Now those two angles are not equal. Okay, the 5x minus 6 and 2x plus 1 are not equal. But I know these arc marks tell me that this is also 2x plus 1 because those two angles are equal. So now I can do 2x plus 1 plus 2x plus 1 equals big angle 5x minus 6. Combine like terms. Subtract 4x. Add 6. And again, we're being asked to find the measure of these angles. So take 8. Substitute into PQT and RQT, which they both are the same. So a measure of angle PQT and measure of angle RQT are both 2 times 8 plus 1, which is 17 degrees. And that is the end of section 1.4. Next, section 1.5 is our last section of the chapter. I would encourage you to go ahead and try the 1.4 homework at this point.